hello everyone to this week's class. We will just sort of continue from where we ended up last class. That is on the topic of state machines, and this time we will kind of include that, or all of that, into a coding exercise. So that's today. It will be just this one task for the whole class today, and because I'm not there, I cannot really help you there in place. But I can probably like exist as a helper on email or something, and also it will work as a sort of homework which you can take with you to home. In this case, we will sort of use the same kind of stuff that we learned last time, meaning that we will have like a machine with some inputs and some outputs, and the state that we are in will sort of influence which output you are giving. And so it will become more clear in more examples. This is the drawing we had last time as well. So there are some inputs, right? So in our case, I mean, like in theory, you can just code it in any way you want. I do have some starter codes, and those are using key presses as the inputs for the machine. So I guess that one, like the inputs would be key presses, and in that case, alphabet would be like all the keys that we can just read. Yeah. Outputs, that's something that's kind of up to you. The demos that I attached to this, that I will show later, there are two possible ways. One is just mapping to like a color of a frame, and another one is mapping to like a different sound which is being played in a loop. So it's sort of like a DJing machine, if you will. But it really kind of will be really open-ended, this task. So you can completely get off rails and not use the starter codes as well, and just like map it to whatever you want. And then maybe most importantly, there is something in the middle, which is the state machine, and that has to have some kind of state that it's sort of tracking where it is on, and sort of some behavior of reacting on different inputs. And in this case, we will not have to have any accepting states. We will basically just read whatever the state is currently and then map that to the output. Okay. Yeah, does that make sense? How can I see? Does it make sense? Okay. Good. So to continue. So one of the examples that we have shown and looked at the video actually of last class was this, that you can use state machines as a model of a simple AI in a game. And so each of the agents in that game would have this sort of machine in them, and they would remember that they are in the state of searching. And if something happens in the environment, they will get like a signal from it, and it will move them there. And so, like we were saying last time, this is kind of more complicated than what just the mathematical notation is. So what we were drawing on paper before was basically more rigorous, kind of following the mathematical notation. In this case, I don't think that they follow exactly the same things. So, for example, the signals can be anything, and yeah, like you can have some like time simulation there. You can have way more complicated things which are moving from one state to another, right? Last time, I think some people were trying to have like length of a string or something would be the thing that moves you from one state to another, which in the math formulation doesn't happen, but in this one we can probably actually do that. Okay. Also, and we will see that later, something like randomness is not something that you cannot really have in the state machine as defined previously, but we can completely have that in the code, right? We can just have a random like R or something cause just moving into a random state. So that's something that we can kind of just start with the standard state machines as a formulation and just move on from there. Okay. So in our coding, this is something we will have. Some inputs, meaning the key presses. Some outputs, meaning, so what is coded is the color or the looping sample, but it could be also just image, it could be anything you want. At this moment, you will probably have to like search different libraries or something and find how you would show an image in the stuff that you have. Or you could loop different videos or something, or it depends, right? Like, and yeah, for that it is really open-ended. So you will have to spend some time searching forums and some examples and stuff, just like trying to figure out how something that you want to do is done. Okay. Okay, and so I think also if you have some really great idea and it doesn't really work, it doesn't matter. Like you can start with something simpler of these two, and then we can, over the course of maybe the next class or something, add to that code and like make it as a bigger project. Yeah. Okay. So we have seen these diagrams before as well. This is another one. I guess I should have hidden this text, but what this machine does, this would be something I just wrote on a paper, right? So there is no code there yet. So what this machine does is it starts somewhere, and with a key press of n, let's say that's like n like next, you just go from one state to another, to another, to another, to another. And so this is just basically flicking through things, through these 4 states. You can imagine that in code you could do that quite easily, even without using state machines. But having some sort of like state machine formulation there will help you in the event that you want to maybe change that state machine or something. So you would like to redraw these arrows or make some new states or make some new transitions. Yeah. And as you may notice, the difference with this one and the one that we were using before is that we don't have an accepting state. So in the definition that we had last time, there has to be like at least some accepting state, and it will decide if the word is accepted or not, right? It splits the whole world of possible words into 2 domains. One is all the accepted words, and the second one is all the not accepted words. In this case, that's not what happens. In this case, it basically just gets some stuff in, and then it ends up somewhere. It ends up in 1, 2, 3, or 4. And basically also it's just running on the, all the time, right? Because we keep feeding it with new key presses. So it's just running there in the background, and we are kind of slowly changing the state of it, depending on what signals do we throw into it. Right? Which is actually very similar to this one, because this is also something which is sort of staying in the minds of all the NPCs in the game, and you just throw some inputs at them and they change their behavior accordingly. Okay. Right. So in your designs, you don't have to use just n like next, like one key press. There could be way more complicated behavior as well. Right. So how to kind of like formalize this a little bit more? We have something similar like last time, right? We have a bunch of these are something just that we saw last time as well. But in this case, there are more states than we had before. So this is 1, 2, 3, 4. We do still have one starting state, just to know where the code initiates, basically. We do have an accepting alphabet, which is basically the whole keyboard in theory, right? And we have transitions. So these are the kind of, I guess you would have this saved maybe in a dictionary or something, right? You would have a, or maybe dictionary of dictionaries or some wild stuff like that. Like implementation details will be left sort of on you, but there should be some way how I can like write all the transitions into the code, and depending on those transitions, it will kind of do this. And then eventually the last thing, which is kind of also the important one, is we need some mapping. So we no longer have accepting or not accepting, but we have the state number or something. If you want, we can have this just as a number, and we would like to map that number into some output that is being kind of every loop that we go through updated. And so in this case, it could be, for example, if I am in state 1, I am showing red. If I'm in state 2, I'm showing orange. If I'm in state 3, I should show green, and maybe 4 is blue. And so if this is an application, it runs, and I'm kind of, it starts with red. If I press the N once, it will turn into showing orange. And then if I press it again, it will turn into green, etc. And so again, this is something that you could very easily just program without state machines at all. But what if we then want to get this simple machine and, let's say, do something wild with it, such as having maybe just more states. So this is the same thing as before, right? This is we had 4 before. This is with 6 states. Cool. So we have some starting state, and then some transitions, and then we have n like next going between them. Cool. So we can at any moment also just add more states. Add more transitions, which would be maybe something like, if I want to go back, I will have a state or like transition which would be going back between all of these states, right? So I'm drawing it in with this one, but in theory that could be with all of those. I could have some like, maybe just some more wild jump, so maybe going from one state to the opposite side, and that could be something like, I don't know, flip. So I could map that to a letter called F, for example. And if I F again, then it will kind of just flip again, right? From this side to this side. And so from a very simple behavior we had at the start, this is slightly more complicated, and you could have these flipping states here and here. You could have the back tracking here as well. And so you could kind of increase the complexity of the machine over time. And so what is this thing at all? So you could start with a very simple machine, something that was in the slides or at the start of this, right? And then slowly add more complexity to it. So you could add more transitions going back and forth, and yeah, I don't know. All of this is sort of just the behavior somehow mapped or modeled. So we are kind of making the behavior more complex. Cool. And so what is this nonsensical example doing at, like, what is this basically? Well, I had an idea that this could be somehow linked to something like this. So you can have something like just colors. So different state is showing a different color, and these states sort of could correspond 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 colors which could correspond to this circle, right? And then in that moment, going forward and backwards, right, next and back, could work, right? Because you're just like cycling through that circle, and then F would be flipping to the complementary color, right? So in that case, it's actually a thing that can be used to navigate colors. So it's sort of like a fun interface to play around with colors. Right. It doesn't have to end there. You can basically map it to whatever you want. So colors, I think, are just a relatively simple example to start with, and then we can maybe you could also start with the colors, but then have something more complex mapped to it later. Okay. So the task, kind of concretely, would be to have some inputs at one side, and then have some outputs on the other side. And this is the part that I helped with already, because there is some starter code. But the real task would be to build the state machine inside that code. So that is really up to you, sort of how you decide to implement it. But it should follow it should basically, very importantly, it should allow me to look at it, change the state machine that is in there, and like actually change the behavior that it's doing. And yeah, so it should be sort of modular in that sense, right? So with this task, I think, we will look at the examples in a bit, but I think a good starting point would be to make those examples run, of course, but then to just draw, just figure out actually what would you map as inputs to outputs, like what type of problem seems exciting to you, or what kind of application could be exciting with this, and then mapping or writing down just on paper the behavior of the state machine that you want to do. So basically, actually writing down sort of this thing first on paper before you start doing all of that in code, right? And then when you have that, you can even have like a version 1, which is simple one, which is maybe 4 states, so it's easy to write into the code, and then more complicated one for later. When you have that, you can start writing it into the code. So this will be work for this class, and also for it will sort of also remain as a homework for until the next class. So the one that we meet in somewhere in April, and the homework means that I would like to ideally look at the drawing, actually not ideally. I would like to look at the drawing of the state machine that you designed as well. It can be something simple as well, but like it can be something more. Yeah, it's an open-ended task, sort of. I'm leaving it up to you in the sense that you can go as wild as you want or as simple as you want as well, but in theory it should have more than 5 states, just so that we see some complexity in there, right? Cool. Just so you know, like, don't be scared about this homework. It's not something... If you get stuck with the programming part, it's relatively okay, right? We can... I think I would like to see some examples or something running the next class, but then we can sort of, at the end of the next class, sort of maybe start working on that project again a little bit more, and I can like help you get unstuck if someone has some problems with this. I can probably also write a sort of referential solution sometime during the next class, right? So you will have a lot of time now to think about this. Yeah. Okay. Right, let's look at the codes. Here, Python files, which are basically the starter codes. There are some files that you can also download, which will then be, these are 4 sounds that can be used in one of the examples. Okay, let's start with one of them. Let's start with the matplotlib. Oh yeah, and by the way, I'm putting 3 here because sometimes it's hard to make any of this work on your PCs, right? So at least one of them should, I'm hoping. And it also kind of allows you to just pick one which works, and then you might have to install some libraries, but maybe some of them are already pre-installed, and maybe some of them are easier to install. So at least you have three sort of possibilities here. Matplotlib is something we have used in the class before. Turtle graphics is something you have used way back, right? But I think it also communicates with Kinter, so there might be some installation needed as well. Maybe not. And then there is Pygame, which is another library that you can use, and that's kind of, it was the easy one that I found to map into audio, so that's also quite like, exciting. Cool. Let's look into the codes. So this is the first one. I will just click them right. So the first one is the matplotlib, which is using this library. There is a lot of stuff, which is a lot of the code, which is something you don't have to really touch. So this function will set the color of the thing of the figure into the color that you ask it to. So you can like call it with blue, and it will set it to blue. You can call it to red, and it will set it to red. So this is something kind of managing the output for you, but you still have to send correct words for it. This demo right here basically maps any key event. That means like any key press, it maps it into this function. And so this function will be called every time you press a key. And if we kind of catch the right key or something, maybe the right actual right key or left key, it will do something with the color. If not, it's fine, and we don't have to worry about it. So this behavior here is doing that if you press to right, it will directly change the output to blue. If you press to left, it will directly change the color to red. This is something, it will work as an example, but it's something that we don't really want because this is too simplistic. There is no state machine happening there at all. So basically, instead of this part, you will somehow need to place in the logic of the state machine. So there should be something like, yeah, there are some hints here in the code. in all of the examples. You will probably have to save the state of the machine somehow, and maybe you can filter the alphabet. You don't have to, but it might be helpful to like filter the alphabet in the ones that you in the letters that you are reading actually, and then there will be a lot of transitions, and so in here there could be some kind of just very nested code of saying if we are in state 0 and if the key is right, then set the state to 1 or something, right? That would be the simplest way, because you are manually writing all the states, all the transitions there. There would be a lot of code here, but it's a way how to do it. Maybe the more elegant way would be to have a sort of dictionary here, maybe even dictionary for every state or something, and you could kind of encode the behavior outside, and then here just change the states depending on the dictionary values, right? The case in here is that we have some initializations that you don't care about, right? But there is some sort of never-ending loop, and that never-ending loop reads some keys, and yeah, basically don't worry about all of this. Here is something that you can change, right? If key name is left, then do something that sort of then change the color or change something. And so play output, this variable, is something I set up here to kick.wav, and kick.wav, if you look here, is this file. So what this code does is that in the loop it basically just plays this one thing over and over, but if you press left it will change the thing that is being played over and over into something else. And the possible outputs, I just made it simpler here, sort of, so it either changes into this wav or this wav, right? It's just choosing one of the two. So again, in this case, this is too directly, this is written too directly, right? We don't want the behavior to say, hey, if I go left, do this, if I go right, do this, because instead of that, we somehow want to encode this more complicated behavior.
This is a short demo of showing of the demos that I prepared for this class. So let's start with this one. This was the first one we saw. In this case, it's just showing an empty figure, and then if I'm pressing keys, it will read it here, right, and tell me what I pressed. And then if I'm pressing the ones that I programmed it with, like left or right, it will change it, right? The only thing is that Matlib prot has some keys already reserved, so something like S will make me save it, even if I don't want it. Q will kill it, etc. So this is a good demo, but just note that some of the keys are reserved. Let's see, Python. This one, it's the same thing, exactly the same thing, but I am kind of like I'm not getting reads here of different keys presses, but if I press left or right, it also is changing the one. And this one is without any like binding to S, Q or something already existing. So it's kind of maybe cool to start with an empty one. Okay, and then the last one. This one might need you to run command like this, something like this, of installing the Pygame, or sometimes Python 3, or it really depends on what like where your Python lives. So you will have to figure that out. Then if I have installed it, then I can show you this demo, and it's in a loop playing the same thing. So this is the same sound. If I press left, it will change that into something else, and so now I'm looping if I press left or right. Yeah, okay, enough fun. You can map it to these 4 tracks, so you have more stuff to play around with, and also it would be fun to have something more complicated in the middle than just you reacting to left or right, right? aka use a state machine. Okay, cool. I think this is it then.